Question. Please solve this problem step by step. The dimension of rectangular beam section and the reinforcing steel provided are shown in Fig. The section is subjected to a characteristic moment of 30 kN. Determine the maximum stress in steel and concrete. The materials are M20 grade concrete and mild steel reinforcement. Also find out the moment of resistance. Please write again step by step. Concrete stress in Un per square millimeter equals steel story in and Nm equals moment of resistance. Comp in KNM equals moment of resistance. Tension in KNM equals moment of resistance of section in KNM equals step-by-step solution. Given data, width of the beam B equals 200 millimeters, depth of the beam D equals 400 millimeters. Effective depth, D equals X to be determined. Reinforcement, 3 bars of 16 millimeters diameter. Total area of reinforcement, AST equals 603 square millimeters. Characteristic moment, M equals 30 kN equals 3010 nmm. Concrete grade, M20F underscore CK equals 20 megapascals. Steel type, mild steel F underscore Y equals 250 MPa. Step 1, determine effective depth D, assuming the effective cover equals 25 millimeters. D equals 400 minus 25, 375 millimeters. Step 2, check if the section is under-reinforced. The limiting moment of resistance for a balanced section, M underscore limit equals 0.36 times F underscore CK times B times X underscore U underscore max times D is 0.42 times X underscore U underscore max. For M20 concrete, X underscore U underscore max, D equals 0.53 for mild steel, taking X underscore equals 0.53 times D, equals 0.53 times 375 equals 198.75 millimeters, using the formula. M underscore limit equals 0.36 times 2200 times 198.75 times 375, 0.42 times 100 nmm equals 39.85 kNm. Since M underscore limit greater than M, the section is under-reinforced. Step 3. Determine neutral axis depth X underscore U. From the equation of equilibrium, 0.36 times F underscore CK times B times X equals 0.87 times F underscore AST, substituting values, 0.36 times 2200 times X underscore U equals 0.87 times 250 times 603. 1,404 equals 131,152.5. X underscore U equals 91.35 millimeters. So neutral axis depth X underscore U equals 91.35 millimeters. Since X underscore U less than X underscore U underscore max 198.7, the section is under-reinforced. Step 4. Find maximum stress in concrete sigma underscore C. The maximum stress in concrete at the extreme fiber is sigma underscore C equals 0.36 times F underscore CK equals 0.36 times 20 equals 7.2 Un per square millimeter. Maximum stress in concrete sigma underscore C equals 7.2 nm. Step 5. Find maximum stress in steel sigma underscore S. Strain in steel epsilon underscore S equals D X underscore U. X underscore U times 0.0035 equals 375 to 91.35. 91.35 times 0.0035 equals 0.01085. Since epsilon underscore s greater than yield strain 0.001 to for mild steel, thus the stress in steel sigma underscore s equals 250 Un per square millimeter. Step 6. Calculate moment of resistance MR. MR compression side M underscore R comp equals 0.36 times F underscore CK times B times X dia 0.42 times X underscore U equals 0.36 times 20 times 291.35 375 0.42 times 91.35 equals 30 kN. Moment of resistance compression side equals 30 kN. MR tension side, M underscore R tension equals 0.87 S times dia 0.42 times X underscore U equals 0.87 times 250 times 375 to 0.42 times 91.35 equals 30 kN. Moment of resistance MR tension side equals 30 kN. Final answers: concrete stress equals 7.2 mm. Steel stress equals 250 Un per square millimeter. Moment of resistance compression side equals 30 kNm. Moment of resistance tension side equals 30 kN. Moment of resistance of section equals 30 kN, which matches the given moment, so the design is safe.
Hello guys, watch this video and enjoy yourself. Please don't forget to share, like and comments on this channel and subscribe to watch the next video.